these two are going to be a little bit different. So if you are asked to find when this function is going to give you a value of 2, you come up here at 2, and let's see it, level 2, when y is 2 all the way across, when will it intercept my parabola? It's going to cross it twice, but it's going to cross it on this one is somewhere between 2 and 3. So it's going to be some decimal. And this one right here intercepts it somewhere between 3 and 4. So if they are nice decimals, they're going to be rationals. But if they are nasty decimals, they are going to be irrational. So irrational decimals, they're on the number line, but they're kind of nasty, like all these square roots. So if it's between 2 and 3, it's probably square root of 3-ish, somewhere in there. Or if it's a rational number, maybe it could be like a 2 and a fourth. So who knows? It's hard to tell, because it's hard to estimate when it comes to decimals. This one, when it equals 4, 4 is clear up here, and it never is going to intercept 4 in the real numbers, but it will in the complex, or maybe in the imaginaries. So your answers are either going to be purely imaginary, so an imaginary answer that's purely imaginary is just like a 4i or a negative 4i. But if it's complex, it could be 3 minus 4i. It's a combination of a real and an imaginary. So it's going to be one of these two groups right here. Okay, so now, which you got 4 quadratics. Which ones are going to be easiest solved by factoring? So the only way to tell is to get them in standard form. Ax squared plus bx plus c is 0. So get everything on the same side. So x squared minus 2x minus 75 is 0. This one's going to be 5r squared minus 11r plus 30 equals 0. This one is x squared minus 7x plus 10 is 0. And this one is m squared plus 10 plus 10. So that's plus 4m. Minus 90 is 0. Okay, now factoring. I definitely use when a is equal to 1. So I am going to dismiss this guy right here. We're not even going to try and factor this. So do there exist two numbers, two integers, that multiply and give you 75 and add and give you 2? Alright, so 75, let's see what goes into 75. 75 is 1 and 75. 3 is going to go in. 3 and 25. 4 is not. 5 and 15. And I think that might be it. So can you combine these anyway and get a negative 2? And the answer is no. So let's see about some of these other ones. Okay, can you times and get 10 and add and get 7? And that one's a little bit easier. And we should be able to find it with x minus a 5 and x minus 2. Because a minus 5 times a minus 2 is 10, but a minus 5 add a minus 2 is a minus 7. So your solutions, x is going to be 5. It's not really or, it's 5 and 2. There's two solutions. 5 and 2. Okay, this one. Can you find two integers that multiply and give you 90, add and give you 4? So I'm not real sure about the 90s. 1 and 90, 2 and 45, 3 and 35, what's 5, 5 and 18, 6 and 15, what else is there, 7, no, 8, 9 and 10. Alright, so can we get a 4 out of any of these pairs? So we gotta conclude that this is probably the only guy right here that is going to be solved easily by factoring. These solutions are not integers, so they're probably they're either some rational or irrational, or maybe even some imaginary solutions or complex. Okay, the next bunch. Which ones are going to be easiest for the quadratic formula? The quadratic formula, the hint is anytime a is greater than 1, then that's probably your quickest bet is to use quadratic formula. So if I'm minus 6x minus 6x, I got 9x squared minus 2x plus 3 is 0. This one I'm definitely going to use quadratic formula. Minus 5x minus 5x, 12x squared plus 10x plus 5 is 0. This one I'm definitely going to use. I'm going to get v squared plus 3v plus 3v plus 9v plus 18 plus 18. And then this one, k squared plus 5k minus 1 plus 6 is 0. Okay, these bottom two are really nice. I can factor these easy. This is k plus 3, k plus 2. So k has got to be a negative 3 or a negative 2. And this one, v plus 3, v plus 6. Times this gives me 18, adds it gives me 9. So v's got to be a negative 3 or negative 6. So when a is 1, and I can multiply and get c and add and get b, factoring is the way to go. But the top two are kind of nasty. So quadratic formula is going to be the way to go for those. Quadratic formula, I'm only going to work one of them out. So let's work this one out. A is 9, B is a negative 2, C is 3. Quadratic formula is x equals negative b plus or minus square root b squared minus 4ac all over 2a. So move number 1, you gotta correctly identify a, b, c. So it's going to be x equals a negative b plus or minus the square root of b squared. Now right here, if you do this in your head, you're going to be safe. But if you let the calculator do it, you will get an incorrect result unless you put this in parentheses. Because if you punch in negative 2 squared on the calculator, it's only squaring the 2. So it's going to give you a negative 4. But a negative 2 squared, you got to square the negative also. And negative 2 times negative 2 is going to give you positive 4. You want a positive 4, not negative 4. But the calculator is going to mess you up. Minus 4 times a times c. All of this is going to be over 2 times a. So now I'm going to start punching stuff in my calculator. See if we can figure out what's underneath the square root. So 4 minus 4 times 9 times 3. So we've got x equals 2 plus or minus the square root of a negative 104 all over 18. Okay, now this is an indicator that's going to be imaginary, so I'm going to go ahead and take that imaginary out. And I'm going to express this as x equals 2 plus or minus an imaginary times the square root of 104 all over 18. I know 104 is not a perfect square, but let's factor out what squares we can. So 104, I'm going to erase some more stuff. Okay, 104. Square root of 104 is the same thing as 2 times 56. 56 is, or not 56, I think it's 52. 52 cut in half is the same as 2 and 26. 26 cut in half is 2 and 13. So the square root of 104 is the same as 2 cubed times 13. And I can pull a square out of there, so that's going to be the same as 2 times the square root of 26. So I'm going to change this now to 2 plus or minus 2 imaginaries times the square root of 26 over 18. And 2 and 2 and 18 are all even. So I can simplify this fraction. I divide those all by 2, and that's going to be 1 plus or minus I square root of 26 over 9. And that is your final answer. And those are complex because you have some reals. Right here, the reals, 1/9, and some imaginaries. So if you got a combination of both, your answer is complex. Completing the square. Those are going to be easy to recognize because your C is going to be kind of a bum C. There's going to be no way to get two integers that multiply to get C and add and give you B. So same move, get everything on the same side. So this one is x squared plus 6x minus 34 is 0. This one is x squared minus x squared minus, let's see, plus 6 plus 6, that's 16x minus 11 is 0. This one is x squared minus 11x plus 28 is 0. And this one is n squared minus 5n plus 4 is 0. Okay, so let's start at the top. What's going to times and give you 34? Add and give you 6. 34... I think only has 1 and 34, 2 and 17. So that's a bad C. This one is going to be complete the square. Times to give you 11, add and give you 16. 11 and 1 are your only options. That's a bad C. So this one. Times give you 28, add and give you a negative 11. And that's 4 and 7, so I can go x minus 4, x minus 7, so that one's slick. X is 4 or 7. And this one's got times give you 4, add and give you negative 5, x minus 4 times x minus 1. Okay, so the bottom two I can factor. The top two, because my c's are not really what I want, they're messing me up. So I'm going to create a perfect square. I'm going to complete the square. I'm going to get the c to the other side, so I'm going to go x squared plus 6x is equal to 34, and I'm going to replace it with 9. And I'm going to add 9 on this side, and I have to add 9 on this side. Now 9, because it will factor and give me x plus 3 times x plus 3. 3 times 3 gives me 9. 3 add 3 gives me 6. And it all depends on what the 6 is, what the b is. So to find the c of your choice, you want to take b, divide it by 2, and then square it. So now I got x plus 3 squared is equal to 43. And then I'm just going to square root. So x plus 3 is equal to plus or minus square root of 43, because there's going to be one on the left of the vertex, one on the right. And then minus 3, so your final answer is x equals a minus 3 plus or minus square root of 43. Okay, let's look at this other one. I'm gonna figure out what c I want. I don't want 11, so it's gonna be x squared minus 16x is equal to 11. I want half of this, which is 8, times itself, which is 64. So I want 64. I'm gonna add 64 here, add 64 there. And I'm going to factor it, so it's going to be x minus 8 times x minus 8. 64 and 11 is 75. So x minus 8 squared is equal to 75. Square root this. X minus 8 is equal to plus or minus square root of 75. I know square root of 75 is the same thing as 25 times 3, so 5 square root of 3 is equal to x minus 8 plus 8 plus 8, so x is 8 plus or minus 5 square roots of 3. Alright, quadratic equation, so you got to find the discriminant. See if you can interpret what kind of roots you're going to expect based on the discriminant, and then find those roots or find those solutions. Okay, the roots are solutions at 0. At y equals 0, or they're at level 0, they're the x-intercepts. So let's get it in standard form. Let's move these 10 n's over. So it's going to give us 11n squared minus 4n's plus 11 is 0. So a is 11, b is a minus 4, c is 11, x equals negative b. So that's going to be positive 4 plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So this is going to give you 4 plus or minus the square root of a negative 468, all divided by 22. Okay, now a, your discriminant, is this negative 468. And I know because it's negative, that's going to be an imaginary, so I'm going to expect the number. I'm going to expect 2 complex solutions. Okay, now find them. So move number 1, I'm going to take the imaginary out, so it's going to be 4 plus or minus an imaginary times the square root of 468 all over 22. Now, I'm going to pull out some squares of 468. 4 plus or minus I. 468 is the same as 2 squared times 3 squared times 13. So this square root's going to undo that square and that square. So that's all over 22. I'm going to have 4 plus or minus a 2 comes out, a 3 comes out. So that is a total of 6 imaginaries on the outside. Underneath 13 over 22. a 4 and a 6 and a 22, all divisible by 2. So final answer is 2 plus or minus 3 imaginaries times the square root of 13 all over 11. Next one. How many more are there? There's plenty more. So I'm going to do, of these 3 remaining, I'm just going to do one of them. Because with 2 examples, you should have plenty to go by. So 5n squared plus n, so that's going to be minus 10n plus 4, that's plus 7 is 0. A is 5. B is a minus 10, C is 7, x equals negative b, plus or minus the square root of b squared. So in my head, negative 10 times negative 10, that's going to be 100. That better be a positive 100. Minus 4 times a times c, all divided by 2 times a. Alright, so move number 1, a minus 10 is plus 10. And then under the square root, 100 minus 20 times 7. Is that 140? So is that negative 40? 100 minus 4 times 5 times 7. That is 100 minus 140, so that's a minus 40. All over 10. So take the imaginary out. 10 plus or minus imaginary. Square root of 40. Square root of 40 is the same thing as the square root of 4 times square root of 10. No, that's a perfect square, so I'm going to swap it out. 10 plus or minus 2 imaginaries times the square root of 10 all over 10. Okay, now 10, 2, and 10. Divide those all by 2. So my final answer is going to be 5 plus or minus 1 imaginary square root of 10 over 5. And we'll call that good. So I'm going to skip these next 2. And I'm going to go over some of these. So solutions. Write a quadratic equation that's going to give you the following solutions. So we're working totally backwards. If you have your solutions are 5 and negative 7, it's got to look like x minus 5 and x plus 7. So your equation is going to be x squared plus 7x minus 5x minus 35 is 0. X squared plus 2x minus 35 is 0. That is the equation we're hunting. If you factor that, we'll give you 2 solutions, one at 5, one at negative 7. Now, if you have one solution, this must be at the vertex. So this solution is kind of unique. It is at the vertex. So same way. I'm going to go x minus 7 times x minus 7. And there's actually 2 solutions, but they're the same thing. This is x is 7 and 7. But I don't need to repeat and say, yeah, I got 2 of them. Let's just say it's x is 7. So x squared minus 14x plus 49 is 0. If I distribute that out, minus 7 add a minus 7 is minus 14, but a minus 7 times minus 7 is 49. Okay, you can do the imaginaries the same way. It's going to be x plus 2i times x minus 2i, and this one, if I plug it in here, that will give me 0, and this one, if I plug in here, will give me my 0. So I kind of wrote it in the wrong order, but I'm going to have one of them plus, one of them minus. X squared, x times a minus 2i is a minus 2ix. 2i times x is a plus 2ix, so these 0 out. 2i times a minus 2i is a minus 4. I times I is I squared. and I squared is a negative 1, so negative 1 times negative 4 is a plus 4. So x squared plus 4 is 0. And that works because if I do x squared equals a negative 4 and square root, it is plus or minus 2 imaginaries. Okay, this one, let's change it to 6 and a negative 4 to 6 and a negative 4 thirds. You're going to have to do one with a fraction. So same approach. I'm going to go x minus 6 and x plus 4 thirds equals 0. Okay, now I'm picky about fractions, and I'm picky about irrationals. We don't like them. So we don't want any fractions to show up in my equation. So I need to de-fractionize this fraction. I need to turn it into an integer. And I can if I times it by 3. But if I times the left side by 3, I must also times the right side by 3. Okay, now the left side, there's only one term here. So there's a huge difference between 2 times x and 2 plus x. If you have factors separated by a times sign, there's really only one piece. So if I were to times this by 3, I'm just timesing, even though I've got 2 terms here, or 2 factors separated by a times sign, I only factor one of them. So 2x times 3 is going to be just 6x. But if I have them separated by a plus sign, and I times that by 3, I need to times both of them. 3 times the 2 is going to be 6, but 3 times the x is going to be 3x. So this one looks like this. So I'm going to times it by 3. I'm going to times not both of these groups. I'm just going to times one of them because there's really only one term here. 3 times the x is going to give you 3x. And 3 times 4 thirds. 4 thirds times 3. I make 3 a fraction, put it over 1. 3 on top and 3 on bottom. You can cross cancel. So x plus 4 thirds times 3 is going to be 3x plus 4. So if I times the left hand side by 3, I get x minus 6 times 3x plus 4, and that is equal to, I got to times the right hand side by 3, and that's still 0. So now I'm going to distribute. X times 3x is going to be 3x squared. X times 4 is 4x. Negative 6 times 3x is negative 18x. Negative 6 times 4 is negative 24. So my equation is 3x squared minus 14x minus 24 is 0. And this will give you 2 solutions, one of them at 6 and one of them at negative 4 thirds. Alright, 0, that is just x squared is 0, and 3i, negative 3i, that is x squared equals a negative 9, or x squared plus 9 equals 0, and that is it.